Hey there, everybody. Robert Wilson here, working on a AI villager project for my Southern Hampshire University GAM465. My specialization that I selected for game development was AI because that tends to be the strength of my background, but I've never done it for a game environment. So we're seeing how this goes here. Uh, so what I'm working on is I have some villagers here. So I think that's what it fills in their names. Right now has the text over top, but once the game starts, it fills it in. So I have villager A, B, C, and D working from right to left, and then each of these buildings here are house A, house B. We got house C set up over there, and house D. And then they also have job location A, job location B, job location C, and job location D. These buildings here, I just used the in-game modeling tool here and was just messing around. Made a couple, kind of like a blacksmith style workshop, and a house that I duplicated there. Um, these characters are from the Little Heroes pack. They're cute, but I don't like the way the skeleton's set up on them, so I don't know if I'll stick with them, but that's what I have for now. So essentially what we do is I run a time of day, because I'm using Ultra Dynamic Sky, and I want a 24-hour day to go with a day-night cycle, and depending upon the time of day will determine what the villagers are going to do. So looking at the game mode, actually let's look at the game mode code here. So when it first begins, I set the time of day function, which is coming down here. I'm just taking the that's fmod is the module, so I get the world time in seconds. So every time it starts fresh, it starts off at 0. If I want to do a time offset, because we're doing 2400 seconds, if I want to do a time offset, 2400 or 0000 is going to be midnight. A 0800 would be morning time, so I can set a time offset of what time I want the day to start. What this also allows me to do is if I save the game, when I come back in, I can save that time of what it was in the game. When I come back in, I can just time start offset. I can load that save file in and reset to the exact same time of day that it was when it left. So that's why I went with this method of doing it here. Set time of day is what it calls at the begin play, and then any other time it's called, it's just get time of day, which will just pull in that a variable called start offset time, but it requires no input parameters for the function, so it's a little bit easier to call within the blueprints. Okay, so in the game mode here, begin play, I go ahead and start a timer called update time. I have it play every 1 second for now. Later I'll probably adjust the times for memory savings if needed, and then I go ahead and set the loop. And all that's doing is it's coming set time of day or it's calling get time of day, which was the function that we just looked at that did not require an input, but it returns the time of day. And then I go ahead and set the Ultra Dynamic Sky time of day, so that way you can go through the day and night cycles. And then I go ahead and print that out as a debug right now, just as a G engine up in the top left corner for debug purposes. Okay, pretty simple, right? All right, looking at the villagers, it's a little more complicated, okay? So let's look at the C++ first. Okay, I go ahead and set up an AI perception component. Not needed now, but I may use it later for talking to the players. I set up a enum for villager job. And what that is, it's just up here. None, lumberjack, blacksmith, guard, or unemployed. I can add more jobs later, and then the player can set those in the engine. Right now the default, though, is none. Oh, sorry, the villager name is none, and then I believe, yeah. So the player sets the job in engine. Right now the default name is none, but you can change that later as well. We set a home location and a work location inside the game using the eyedropper. And then here each act or villager can have their own set of times for what time they sleep, what time they wake up, what time they go to work, what time they go home, and what time they start wandering or just socializing. And then update villager clock. And what it is because the game mode has its own clock. each villager, depending upon it, let's say a new villager spawns in the game, that villager needs to know what is the time right now, and it go ahead and gets that here. So what we do is we cast over to the game mode. If the game mode exists, because we don't want to access it without checking, we go ahead and set that villager clock to the get time of day function that we set up inside the game mode. And then we go ahead and print it out for the villager themselves. So we have the game mode printing out, and then we also have the villagers having them print out their times, just to confirm that the villager time and the game mode times are matching up. And this just lets you, anytime you spawn a new villager or anytime you restart the game, the villagers, you could say get game seconds, but that would always start at 0. If you have an offset set for the game mode, then that offset would not be applied to the villagers. It could be the middle of the night, but they think it's daytime. So what we do is we just check, each villager checks with the game mode when begin play starts to set their own internal clock. And then every 24 hours or every day at midnight, it resyncs up just to make sure it's still going. Okay, so in the villager, we set the sync clock. It does it every 10 seconds, and it loops. We update villager clock, which we just looked at that function. And then we have a little function here, change villager state. Okay, so that's an enum that we have here, villager state. And that villager state can have several different values. By default, I have it set to work. You can either sleep, work, home, or wander. And that's the state of what is the villager doing at this time. So this is an internal function here. Change villager state, set villager state. So we'll open up this one here. Set the villager state. So what it does is it says, looking at the villager clock, if it's between this time and this time here, then go ahead and set the enum to that value there. So in this case here, if it's between 22 to midnight or midnight to the wake up time, go ahead and set it to sleep for the nighttime mode. This is definitely going to be changed later because it's assuming that nobody's awake at nighttime. So it's definitely have to do some modifications here. Maybe have it go in a sequential order, because the start time and end time will always be the same for every type of class. But for the basics, they go from sleep, they go into the wake up mode, which would be home. Okay, so based on the wake time to the work time, that goes to home mode. Or after they're done wandering and socializing, they go back to home until they sleep, and it sets to home. Down here, if from the work time start until the socialized time, it sets it to work. And then from the socialized time until it's time to go home, it sets it to wander. So very basic system. It has to go in that sequential order right now. That will definitely be modified right now. But for testing purposes, just to see does this work, it definitely does work. And what that does, it sets the villager state. So let's come back over to the event graph. We set the villager state, and then we set the value on the blackboard. We get the blackboard for the AI controller. We set the value for the key name, which in this case is villager state, and we go ahead and take that villager state that we just set inside this function, and we assign it to as an enum to that blackboard. And then just so I can know what it is, I have text, name, and task. So it takes the character's name, it prints it above the character. So if you look at the viewport, it'll go ahead and put the character's name there, and then the task of what they're working on goes in the block below that. So that's what all I'm doing here is I'm setting the text for that task based upon the enum to string, and then I get the character's name and I set that as well. Pretty simple. When the event begin plays, so I start the timer, I go ahead and update their internal clock, and then I also change the villager state. I run the function down here, change villager state, so it does an initial check. And then as it's syncing the clock, it updates the clock, and it checks or updates their villager state every 10 seconds. And what that does is over here in the behavior tree, so we start with the root, we go with selector. So it's going to check each of these in order until it finds the first one that's true. So if the villager state is equal to work, which you can get from the, so we'll click here. So if the villager state is equal to, we can pick which one of these was, which one of these it is, in this case it's work, then it'll go ahead and execute go to work, which is going to find a behavior task tree. We'll take a look at that in a second. For the work location, once it gets that work location, it's going to move to that work location, and then it's going to go ahead and execute a duration of work time. And then once that duration of time is done, it's going to come back up. It's going to double check. If it's still working time, it might move to another location within the work area and do another pause at that location. So what this could do is you could have a, let's say for blacksmith, you could have a forge. They could pause at the forge for 20 seconds or 30 seconds. Then they can maybe move to an anvil, do anvil animations for 30 seconds, move to a quenching station, then move back to the forge, maybe go back to the anvil again, and they can just go back and forth. And that's something that'll be flushed out later after this proof of demonstration. If they're set to once their state changes over to wander, then work will, after the last wait time, it's going to come back up, check, work will be full, so it's going to go to the next one over, which will check the wander time. And it's going to start wandering to random locations using a behavior task. And then also we have the go home. Later on, I'll add a sleep node, so that way when they're at home, once the sleep villager state is set, they'll go ahead and lay down in their bed. Let's look at the task real quick. AI, we'll look at just one of them. Let's look at home location. So all we do is receive and execute AI. So when it picks up from the behavior tree, that execution, we cast to the villager so we can get the actor location for their home, right? From their home location that we set. So from the villager, what I can do is I can select a villager. I can find their home, scroll down here in the details panel, and then house D. So I'll go ahead and hit the eyedropper, pick house D, and that sets it. Okay, so what it does is it gets that villager, finds their home, sets that gets the location for the actor location, and then it finds a location in the navigation radius for the world. It goes ahead and sets the blackboard value for home location, and then you have to have the finish execute, so it goes. And what we do is we come here to the blackboard, home is the location, and that's the entry key, and then from the behavior tree, when we click on here, the blackboard key, that's the villager state, there we go, the task. So the task was the work location key, and we go ahead and set that to work for which key in the blackboard we actually want to use for that. That's it for the behavior tree, and then what we'll do is we'll move to that work location, plus or minus, whatever tolerance, except a radius of 5. It'll wait for duration. I set a plus or minus, that way everybody's not moving at the exact same time to every single location. It varies things out a little bit. Okay, so that's the quick run down and dirty of how everything connects together. Let's see how it works in functionality. Okay, so we'll go ahead and let's zoom out a little bit. I'll watch villager D here. This is Mika, and because she has the shortest timeline, I put 20 seconds between each of her tasks. The other 3 villagers are actually on a 24-hour timeline, but we'll see Mika cycle through the work, the wander, and then the home relatively quick here, 20-second intervals. So let's go ahead and hit simulate. Okay, so it just set the time to whatever the offset was, so the sun's coming up. Mika is set to work. She went to her work location. Okay, it is 1690 at 1700. Mika will then switch over to wander mode because 1700 is her wander time, according down the details panel. Okay, 1700 just hit. She switched over to wander mode. Now she's going to pick a random location. As soon as it switches over, that doesn't mean immediately they're going to go to alternate location. What they'll do is they'll finish their behavior tree wait time. Then it'll do the check to see did their villager state change. If it changed, then it will go ahead and go to alternate location. Okay, at 1720, it switched to home, and Mika came with, well, not quite as close as I'd like, but she basically came back to her home here. And then every 10 seconds or so, she'll get a little update of where it's going. And you can see, so if we click on the behavior tree, right now she's set to home, so it is running the home path there. Okay, yeah, she moved a little bit closer to home there. And everybody's set up to home right now. We'll hit stop one more time, and we'll look at a couple of the different villagers as they're going through their states. So hit simulate. We're looking at Mika. We're looking at behavior task tree. She's set to the work, so she's now moving to the work, and then she's going to go ahead and wait. Okay, if we look at another villager, Mark, he's set to wander, so he's actually going down the wander tree, and each villager has their own behavior tree. So you just click on them, click on the behavior tree, and you can see exactly what they're doing. Let's see. This is Nabi. We'll click on behavior tree. She's also set in the wander mode. Oh, and they just switched over her time for going home. Just hit, so now she's moving to her home. We can check where she's at. She's villager C, so she went to the villager C home. Okay, about to come up on 1720, so Mika's still wandering. In 5 seconds, she'll go ahead and go to her home. So and 20. She's set to home. Her wait was finished, and she moves home. So what that'll do is once they go home, you can have it set up a subtree to where they might go to a table, they might go to a chair, they might wander around their house, or even out front side of their home until it's time to go to sleep. So a simple AI system for telling your villagers where to go. And then we have the perception system set up so that way we can interrupt the events so that way the player can socialize with those characters. But this is just the initial alpha of the logic, just to make sure everything works together. It looks like the sun's starting to go down, and sunset's starting to come across. If right now I'm doing a 1 second update, I could do a 0.1 second update, and the sun and the shadows will actually move 10 times more smoothly than what they're moving now. But it's not terrible for the initial set. All right, I think that covered everything. If anybody has any questions about how the AI villagers are working, this is just the first draft. It's pretty basic right now, but I'm pretty excited to see where this goes. Another option is, instead of having the different branches here, is on the villager when they hit the different times to go ahead and activate a different entire behavior tree dedicated just to work, or a behavior tree just for wandering around, or behavior tree just for going home, and it'll just swap out the different behavior trees depending upon what state the character has. So that's another way to do this. Lots of different ways to take care of this. This is just the initial draft. If anybody has any feedback on it, let me know. Thanks.